Hi everyone, welcome to the next IC210 video, and we're starting a new unit today on input and output. So this first video is a bit about streams, specifically looking at buffering as well as different types of streams. So what streams have we dealt with so far? Because the concept of streams was already introduced in the last unit. Well, we know that there's some input streams, and you know so far about SED in, that's for reading from the terminal. And you also know about any files from fopen, where you would have the file name and then R for reading. Okay, so those are the two kinds of input streams that we've seen so far. And of course, there's also output streams. So these are streams that are appropriate for writing to. So you know about SED out, and you also know about files from fopen with some file name and W, right? So the W versus the R, W means write, R means read. That creates an input or an output stream. It is actually possible to have a file which is open for both reading and writing at the same time, but that's a bit more complicated. If you think about it, it has to know where it is in the file for reading or writing. It's a little bit strange, so we won't really look at that kind of a stream in this class. And so these are what we know about, but there's a little bit extra detail, which is this thing that I'm talking about here, which is buffering. And well, let's look at an example first, and then we'll talk about what this means and how that works. So here is a program that I've called blastoff.c, and it uses this special usleep function from this library called UniSTD, Unix Standard Functions.h, and that's just going to sleep for this number of nanoseconds. So it's just a half a second in between each one of these things. So you can see it's going to print 3, then pause for half a second, then 2, then 1, then blast off. And so if we compile this and run it, it'll do what we expect. So 3, 2, 1, blast off. Now let's change it. What if we wanted everything to be on a single line? Well, we just take out these new lines, right? Okay, so this is just going to print 3, 2, 1, blast off, just all on one line instead of like before. I haven't changed anything else in the program. And now when I run it, it looks like it's doing nothing, and then suddenly everything shows up. Right, so in the first version, it actually paused between the outputs. In the second version, all I did was take out the new lines, and somehow it just seems like that pausing didn't happen in the same way. It just everything got printed at once. And what's going on there is really buffering. And in C, there's a few different kinds of buffering, but the most common one is what's called line buffering. So some streams are line buffered, which means that the actual thing you're trying to write is only actually sent to the terminal with STD out, or is only actually read from the terminal with STD in once you hit the new line character. So that's why that new line character in the previous example, when we had the blast off example with writing new line every time, that showed up right away. But if you don't have a new line, then it doesn't show up right away. And a lot of times we couldn't really necessarily tell the difference, but in this case, because it's pausing in between, we could tell the difference. And so there's an easy fix for that. The easiest fix is, well, we could use new lines, but if we don't want to use new lines, then we just tell the operating system to please flush the buffer anyway, even if there's not a new line. And so the command to do that is flush. And I don't want to be gross, so I won't really get into why this has a good analogy with how you flush a toilet. But if you think about it for a second, you'll see that this is a good name for this function. So it's just flushing that so that it immediately goes through rather than waiting till it fills up. Okay, so here's our program now, and now when I run it, all I did was add these flush commands, and you'll see that it works kind of as expected, pausing between each thing rather than waiting till that new line to when it all gets sent. So when you see that kind of thing, F-flush is going to be your friend. We don't have to do an F-flush here because the new line causes it to get flushed anyway. And now let's think about what kind of buffering is used in files. And to illustrate this, the easiest way is to look at a program that has an error in it. So here's a program, filebuff.c. It's not a really useful program, so don't think too hard about what I'm trying to do. It's just opening a file for reading, then opening another file for writing. Then it tries to write something into that file, the output file, and it'll tell us on the screen, hey, I wrote something. And then it tries to read a string from the other file. And the problem that's going to happen is that this doesn't exist.txt is a file that does not exist. So when I try to read from it, that's going to cause an error in my program. Remember, we might like it to give an error right here in the fopen, but it doesn't. We have to check ourselves as programmers whether that stream is equal to 0 or not, like we talked about last week. And because I'm not doing that check, it won't notice that there's a problem until it gets down to this line where I actually try to read in. So let's see what happens when I run this, compile and run it. So we have, I'm just going to run the shortcut with make file buff. There we go. And now when I run it, it says that it wrote to the file, and then it says that it's a segmentation fault. The segmentation fault is caused on this line. But now let's see what happens. If I do ls, I see new file.txt. So that's the output file that I'm supposed to be writing to. But when I ask to show the contents of new file.txt, there's nothing in there. So what happened? It looks like we opened the file, but then somehow this fputs writing into that file didn't actually do anything. So you see that the program said the next line said on the terminal, I wrote a line to the file. But this line is supposed to happen before that. It seems like it succeeded, but yet nothing showed up in the file. Why is that? Well, there's a second kind of buffering which is called fully buffered, and that means that it's delayed even more than, it's not just caused with new lines. Fully buffered means that it's going to wait until the whole buffer is full. Depending on the size of the buffer, it might be like 1,000 characters. And that's what's going to be the default for files that we open. And what that means is that normally it's not a problem because when your program ends or when you call fclose on the file, that will write everything into it. But again, if we want that to happen sooner, then we can use the fflush to force writing now. And so again, in this example, if we wanted to force that, we could say either we could say fclose, fout right here. When you close a file, it will always flush the buffer, so that'll work. Or if we said flush, that would leave the file open so we could write more into it, but it would force those contents to be written at that moment. So then there's one more thing to tell you about, which is there's actually one more output stream which doesn't use any buffering at all. So there's one more output stream which we can add to our list here, which is stderr, or standard error. And standard error works just like standard out. It also goes to the terminal, so the anything that you write to the standard error will show up on the terminal screen. But the difference is that it's not buffered at all. So this one is not buffered. And so that can be useful, especially for when we're using debugging statements. So it's good for debugging. Another reason why it's good for debugging is because it's ignored by the submit system usually. So even though it'll show up on your terminal when you run your program, if you write something to standard error, it will actually not show up on the submit system. It'll show up, well, in a different place, but not in the regular output of your program. So anytime that we're writing to standard out, we could also write to standard error, and it'll look exactly the same when I run this program. But the difference is that standard error is not buffered at all, so it shows up immediately no matter what. So there's never any reason to flush standard error because it'll always show up immediately no matter what. So there's our kind of 5 kinds of streams: the standard one, standard in, standard out, and standard error, and then any streams that we open ourselves either for reading or for writing to files.